Whether you're baking a cake or building a house, measuring allows us to be able to benefit from taking advantage of established standards with a common language that gives us the ability not just to be able to measure things, but then to take those measurements and transfer them over to materials or apply them to particular processes. The task at hand often determines the specificity of the measuring systems that we're using for a particular project. So if I'm building a rocket ship to go to the moon, then I might be employing a standard of measure that measures on the order of thousandths of an inch. Whereas if I'm building a stud wall or doing rough carpentry, that standard might fall into the range of tolerance of an eighth of an inch. So among the things that we're going to do today is talk a little bit about the requirements in terms of specificity of our measuring and marking systems, standards that are commonly used to establish the language of measuring things like height, width, and depth of physical objects, or the area of a non-physical space like that I'm trying to build something into. We're going to be looking at a range of different systems that allow us to ascertain length and width, depth and thickness of materials, the radius, diameter or circumference of objects, how to transfer those measurements that we take onto the materials that we're going to be working with. We're going to talk a little bit about the standard that's most commonly used in the U.S. for measurements in general, which is fractions. We'll look a little bit about, at metric systems for measuring. We'll also talk about some measuring systems like wire gauge and sheet metal thickness gauge standards. And we're also going to look at some layout tools that are used for transferring that information from a tool that can measure to a tool that can describe that measurement on those materials. So among the tools that we're going to look at are things like rulers. We're going to look at precision rules, machinist rulers, folding rulers. We're going to look at tape rules. Or tape measures. We're going to look at some long distance measuring systems, systems that are used for measuring the depth of things. We're going to look at tools that give us a combination of measures in a single tool, like a precision combination square, which gives us not just the ability to measure length, but to also ascertain relationships between angles, so perpendicular relationships like this 90 degree or this 45 degree. We're going to look at tools like sliding T-bevels and protractors and scribing gauges and spring calipers and friction joint calipers and dividers and dowel calipers and vernier calipers. And then we're going to demonstrate how these things are used in a studio practice. Knowing and understanding standards also helps us do things like make proper choices in the correspondence between things. So when it comes to things like saw blades, the frequency of the occurrence of teeth on saw blades is measured in TPI, or teeth per inch. And we know that if we're able to understand how many teeth per inch there is on a saw blade, then that helps us then make a determination as to what is the appropriate frequency of occurrence of those teeth relative to the cross-section of the material that we're working with. Another example would be the frequency of occurrence of threads on machine screws. So I know that the machine screw threads are also defined by their diameter and the frequency of the occurrence of those threads on that hardware. So here we have a 3/8 inch rod with 16 threads per inch, and it's 12 inches long. So those, when I'm looking for a nut that corresponds to this threaded rod, I know that I'm looking for a 3/8 inch diameter by 16 threads per inch threaded rod.